So now we're going to return one more time to the question of what a typical data analysis student is like. And we looked at these three questions to begin with, but you may notice that we can only find the mean for one of these questions. So as I said before, you can only find the mean for data that is at an interval or ratio level of measurement. In other words, data that's numerical. So we can rule out both whether you've been in a physical fight, yes and no are definitely not numerical categories, and how afraid you are of being victimized. As very afraid, somewhat afraid, and so on are also not numerical categories. But we can find the mean for the total number of times that you've been stopped in the last 3 years. And so when I put the mean up here, what this is going to show is the value that we would get if we added up all the responses in this data. So our 10 zeros, our 12 ones, our 14 twos, our 6 threes, our 1 4, our 1 6, and our 1 8. If you added up all those values and divided by 45, which is the total number of responses to this question. And if you do that, you get 1.67. So the average number of times that someone in the class has been stopped, in other words, the mean number of times that someone in the class has been stopped, is 1.67 times in the last 3 years. So there's some good things about the mean, which is that it uses all the information in the data. It's very precise, it's great, but there's also a downside, which is that it can be heavily swayed by large values in our data. And to illustrate this, I want to show you my responses to one of the questions in the survey, which is how many times a month, typically, do you smoke weed? This could be recreationally or medically. And so if you look at the responses that I got from you guys, we have 34 zeros, and then one of each of the numbers down the line here. So 1, 3, 5, 10, 15, 25, and 30, and 420. So if we find the mean for this data, it's going to be 12.02. And we can compare that to the other measures of central tendency that we have. So we have a modal response of 0. 34 people in the class said that they smoked weed no times in a typical month, and that's our most common response, so that's our mode. We can also find the median for this data. And if you were to list out all these observations in order, count out to the median position, you'd get a median of 0. So with the distribution in order, the midpoint is 0. So it's another way of looking at a typical case. But if you add up all these observations together and divide by the total number of observations, you get a mean of 12.02. So there's something a little bit different about the mean compared to the other measures of central tendency here. And what's going on is that because we're using all the information in the data, our really, really extreme observations can affect what the mean looks like. And in particular, really, really high observations tend to pull the mean out towards a higher number. On the other hand, if you had mostly high numbers and one low number, your low number would pull the mean down towards that lower number. And you can see this in what happens if we take away our person who's at 420 here from the data. So I dropped that one from the data set. And now we're going to find the mean, median, and mode for the remaining 41 people who answered the question. And what we get here, which is a little bit covered by my head, is the same mode and median. So neither of those is affected at all by the highest value. But we get a dramatically different mean response. So in this data, with our very, very high number dropped, we have a mean of 2.17 times per month, which is hugely different from 12.02 times per month. And I think just eyeballing the data and thinking about what makes sense as a typical case, you wouldn't look at these numbers and say that a typical student in this class smokes weed 12 times a month, right? And think about you. You guys are typical students in this class. Most of you are smoking weed way, way less than that. But we had our one very high number there that pulled that mean out to a higher value. On the other hand, the distribution that doesn't have the very high value has a number that's probably a little bit more close to what we would consider a typical number, although it's still higher than the mode or median, so take that how you will. I'll also just say I love that somebody answered 420 to this question because it made this example so beautiful and so easy, so good for you. All right, with that, I'm also going to talk a little bit about the distribution shape and measures of central tendency. So what we just saw in the last slide translates to a pattern of findings that you get based on what the shape of your distribution is. And if you think back to visualizing data in the last lecture, the shape of your distribution describes what shape the graph is if you look at a histogram. Is it symmetrical with a big hump in the middle and two tails of about the same size coming out on either side? Is it right skewed with most of your data on the left side and a long tail heading out towards the right? Or is it left skewed with most of your data on the right side and a long tail heading out towards the left? And we're going to think about this because the skew of a distribution affects where measures of central tendency fall in your data. And in particular, if you have a symmetrical distribution, your mean and your median are going to be roughly equal. So for example, if you were to make a distribution of something that's almost always symmetrical, like heights, you would expect your mean height and your median height to be about the same. On the other hand, if you have a left-skewed distribution, you'd expect your mean to be less than your median. This is because left-skewed data has a couple of extreme responses that are lower than everything else, and that pulls the mean towards them. If you have right-skewed data, your mean is almost always going to be bigger than your median because it means you have a couple of really extreme responses in the positive direction that are going to pull that mean to a more higher value. So I'm going to show some examples of what this looks like, again using that class data. So an example of a left-skewed distribution would be your perceptions of how likely it is that you're going to get an A in this class. It's left-skewed because most of our data is on the right side, but we have a few people who are very uncertain about the class, who are going out towards that left side. So again, left-skewed means there's a tail that's sort of pointing towards the left, but most of your data is on the right. And if we look at the median and mean values for this data, we can see the pattern we'd expect. So our median is 80. In other words, if you were to list out all the responses to this question in order, the middle of that list would be at an 80. So about half the class thinks they're going to get an 80 or better, about half the class thinks they're going to get an 80 or worse. The mean, on the other hand, is a 73. And this is because when you add up all these responses, the few people who said that they're very, very uncertain about getting a in the class, so the people who have responses that are more in that 0-20 range, those numbers are getting mixed into the mean formula and are going to pull that mean down towards the more negative side compared to the median. We can see the opposite pattern in a right-skewed variable. So one variable that turned out to be right-skewed in our data was how many siblings do you have? And what you can see here is that most of the responses are on the left side of the graph, with a few people who have a lot of siblings and one person who has kind of way more siblings than everybody else. So this is right-skewed because we have this tail of the graph that's pointing out towards the right. And if we look at the median and mean, we see the pattern that we'd expect. So our median is 2, meaning that the midpoint of this distribution of number of siblings is 2 siblings. The mean, on the other hand, is 2.9. And this is because when you add everything up, that one value that's a bit higher than the rest is going to pull the mean out towards the more positive side compared to the median. You can also see a really dramatic version of this with that how many times per month do you use marijuana question, which I've graphed here. And as you can see, the graph looks completely ridiculous because we have 34 zeros, a couple of responses that are all 30 or less, and then one response at 420. So we consider this to be extremely right-skewed. The vast majority of our data is clumped on the left side of our graph, and we have one response that's way, 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 way out there. And we can see that reflected in this pattern of how big the median and mean are compared to each other. So we again have a median of 0 here and a mean of 12.1. So what this means is that when you look at a mean and a median, you can know almost without having to look at the distribution what shape that distribution is likely to be. And I'm guessing that whoever put 420 didn't think I was going to talk about it for like 20 minutes straight, but you know, I'm glad you did. All right, so what this leads me to is one of these things that you should always be looking out for when you're seeing statistics in the media. And this is a headline that CNN actually ran. And they said some savings measures show households are flush, but consumers are spending every dime they make. And they made this claim because they said that the average US household has a net worth of greater than $400,000, but Americans are saving 0% of their income. So that's a little crazy, right? Are we really spending $400,000 a year on average? The answer is no. And the reason for this is that this article is looking at a mean rather than a median in describing the net worth of US households. So if you look at the actual numbers, because they rounded here, the mean net worth is $395,000. But the median net worth was only $86,000, which is a huge, huge difference. And when you think about $86,000, it might still seem like a lot of money, but when you factor in people's housing and college and all sorts of other debts that pile up, it's a little bit less crazy that that's the amount of money that is not being saved on average, especially compared to $400,000 a year. And what's happening here is that we're looking at a really, really, really right-skewed distribution, where most US households are making a fairly modest amount of money. But some US households, the Jeff Bezoses of the world, are making an obscenely ridiculous amount of money. So that tail goes way, 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 way out in the positive direction, whereas most people are clumped around 86,000. We've got half of people under, half of people over. We have a few extreme cases that are making, you know, millions and billions and bajillions of dollars. And because of that, those few cases get factored into the mean calculation, and that makes it seem like US households are making a whole lot more money than they are. So if you ever see in the news something telling you about an average, take a peek and see if you're looking at a mean or a median and think about what the distribution might be like. Because otherwise you get some misleading statistics like this one. So I'm going to close this lecture by talking a little bit about which measure of central tendency you want to use in different situations. And I'm going to show this summarized in a table. This table shows you, for each of these measures of central tendency, the levels of measurement that you can use it for, how much information it gives you, and whether it's sensitive to extreme values. So starting with level of measurement. We already covered this on the slides. But the mode can be used for data at any level of measurement. So whether it's nominal, ordinal, interval, or ratio, you can find the mode. The median can be used for ordinal, interval, or ratio level data. So as long as it's not nominal, you can use the median. The mean can only be used for interval and ratio data. So what this first column tells you is that if you have nominal level data, your only choice is to use the mode. You can't use anything else. So if you're looking at something and you're looking at a nominal level variable, if you were asked to find a measure of central tendency, the only measure of central tendency that you could find for that would be the mode. But let's think about these other levels of measurement where we have more options. In general, you want to use a measure of central tendency that's going to give you more information rather than less information, as long as you're not going to run into problems. But we're going to start with this second column here, which says how much information are we getting from each of these. As I mentioned briefly before, with each of these measures of central tendency that we talked about, we're getting more information each time. So the mode, you're only looking at one value, and it's not telling you a whole lot about any of the other values in the data set. You could literally change every other value that you have in a data set, and your mode would stay the same, as long as your most common value is the same one. The median uses more information than that, because now you're getting information from the other values about where they fall in line with everything in order. So if you change around the values in your data set, it will change what your median is, because the order will change. But you're not actually using the values of those observations, you're just looking at where they fall in line. The mean uses the most data because you're using the actual value of every single observation that you have. So every observation gets counted into that mean score. So as a general rule, the mean is the best measure of central tendency when you can use it because it gives you the most information. If you can't use the mean, use the median because it gives you slightly more information. And the mode gives you the least amount of information at all. It's not useful in many cases, so really you don't want to use the mode unless you have to, which would be if you had nominal level data. But the mean is not always the best measure of central tendency to use. The reason for this is that, as we just demonstrated, it's sensitive to extreme values. So for example, if you wanted to actually provide information on the amount of money made by US households, you wouldn't want to use the mean, because the figure that you get from the mean is really misleading. It's pulled out way too far towards those extreme values that you have where people are making a lot of money. Same thing for the marijuana use question. If you were looking at that original data there that includes 420, you wouldn't want to use the mean because it's going to be misleading. People in this class aren't actually smoking weed 12 times a month. It's just that having that really big number in there inflated the mean unnecessarily. So the general rule is that you want to use the mean when you can, unless you have extreme values in your data, in which case the median is going to give you a more accurate picture of what's going on. So that's all I have for you guys today. As a reminder, the problem set is going to be due on Sunday at 11:59 p.m. as usual, and feel free to reach out with any questions. Otherwise, have a great week.